Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today we review for the Chapter 5 test that is tomorrow. I didn't get any emails from students requesting me to do any problems, so I won't start with those. But do any of you have any specific questions you'd like me to look at this point? All righty. In that case, I will just highlight some things. I want to start with section 5.4, Polynomials, and I want to review what we did in that section. We talked about the idea of a monomial, a binomial, a trinomial, and just polynomials in general. A monomial has one term, a binomial 2 terms, a trinomial 3 terms. Polynomials include anything from 1 term on up to whatever. Okay, technically it bothers me that a monomial is called a polynomial, but math books tend to do that, so I will go with that as well. Any questions about that? Okay, let's say we have the following: negative 4x cubed plus 7x minus 3. This is a trinomial because it has 3 terms. The first term is negative 4x cubed. It is a variable term, and its coefficient is negative 4. The second term is 7x. It is also a variable term, and its coefficient is 7. The third term is negative 3. It is a constant, and its coefficient is negative 3. Any questions about that? Okay. The degree of the first term is third. It's a third degree term because of the 3 exponent on the variable. The degree of the second term is 1 or first because of the implied 1 on the variable, the coefficient. The third term is of 0 degree. There is no variable, so it's as if though there was x to the 0 power, which is equal to 1, and 1 times 3 would still be 3. So first term, degree 3, second term, degree first, third term, degree 0. The degree of the entire polynomial is equal to the degree of the highest powered term. So the actually, let's specifically say the trinomial is of third degree. Now, a misunderstanding that students often have, they think that the degree of the entire polynomial is equal to adding up all the exponents and all the variables and all the terms. Not the case. You just look at the highest powered term. This is a third degree term. This whole thing is a third degree polynomial. So be careful with that. Any questions about that? All right. Next, we had some things to do with evaluating an expression. And the thing I want to stress here, let's see here, we've got negative 9x squared plus x minus 4, and we are to evaluate it for x equals negative 1. When you are substituting a number in the place of a variable, you should always put parentheses around that substitution. So this becomes that plus that minus that, okay? Order of operations. You do the exponent first. So -1 times -1 would be a +1. So -1, the quantity squared becomes +1. Excuse me, -9 times 1 plus -1 minus 4, -10 minus 4, -14. So do be careful with the negative signs. Any questions about that situation? Let's take a look at a situation where we're substituting for more than one variable. Let's say we've got a cubed minus 2ab plus b cubed, and a is -2 and b is +3. So we get -2, the quantity cubed, minus 2 times -2 times 3 plus 3 cubed. Again, when you replace a variable in an expression with a constant, a number, put parentheses around it to keep all of the original operations intact. -2 cubed would be -8. And then we've got what? -2 times -2 would be +4 times 3 would be +12. And then +3 cubed, which is 27. -8 plus 12 is 4. 4 plus 27 is 31. Okay. Any questions about that situation? All righty. Well, that takes us on to section 5.5, adding and subtracting polynomials. So basically, this is getting rid of grouping symbols and combining like terms. So for instance, let's say you've got something like this, 3q squared minus 5q plus 7 plus the quantity 2q squared plus q minus 12. Even though these are like terms, until we get rid of the grouping symbols, we don't want to try and combine them. We need to be careful that we don't. So if there's nothing in front of a set of grouping symbols, we can drop the grouping symbols and just rewrite the polynomial. If there's a plus sign in front of the grouping symbol, it's like there's a +1, and distributing a +1 basically gives us the same quantity that was inside the parentheses, but without the parentheses. Okay. Now, once we've gotten rid of the grouping symbols, we can combine like terms. 3q squared plus 2q squared is 5q squared. Minus 5q plus q is minus 4q. And plus 7 minus 12 is minus 5. So there's our final answer. Any questions about that particular problem? Okay. Now, let's take a look at a situation where we're subtracting polynomials. Let's say we've got 2b squared plus 3b minus 5 minus the quantity 2b squared minus 4b minus 9. Here's where we have to be really careful. We can't combine like terms from two different groups before we get rid of the grouping symbol. For instance, if I said, well, 2b squared plus 2b squared is 4b squared. The problem is, though, I'm going to be distributing a negative sign or a minus sign, so it's technically going to end up being 2b squared minus 2b squared in the final analysis. So nothing in front of a polynomial inside of a grouping symbol. We can just drop the grouping symbol. With a subtraction sign in front, it's like we're distributing a -1. So we get minus 2b squared. Minus times minus is plus 4b minus times minus is plus 9. Now combining like terms, those go together, those go together, those go together. 2b squared minus 2b squared is 0b squared. 3b plus 4b is 7b, and minus 5 plus 9 is plus 4. So there's our final answer. Any questions about that situation? Okay. Let's see, let's do one with fractions. So how about this situation? Let's see, we've got 4/5 t to the 4th power minus 1/3 t squared plus 1/2 minus the quantity negative 1/2 t to the 4th plus 3/8 t squared minus 1/16. All right, let me make sure I've got that copied correctly. That looks good. Okay. 4th. So the first thing we want to do now is get rid of the grouping symbols. The first grouping symbol I can get rid of because there's nothing in front of it. So 4/5 t to the 4th minus 1/3 t squared plus 1/2. There's a subtraction sign in front of the second grouping symbol. So we'll distribute the negative, or the -1. Negative times negative is positive 1/2 t to the 4th. Negative times positive is negative 3/8 t squared. And negative times negative is positive 1/16. All right. Now, to combine like terms, I need to add or subtract their coefficients. So their coefficients need to have the same denominator. Let's start with the highest power of t, which is t to the 4th power. Okay, so we have 4/5 t to the 4th plus 1/2 t to the 4th. So I need to find the least common denominator of 5 and 2, which is 10. So I need to have so many tenths t to the 4th plus so many tenths t to the 4th. I'm going to take 4/5 t to the 4th and multiply it by 2/2, because that gives me 8/10 times t to the 4th. I'm going to take 1/2 t to the 4th and multiply it by 5/5, because that gives me 5/10 t to the 4th. So now I have two like terms with the same denominator of their coefficients. 8/10 plus 5/10 would be 13/10 t to the 4th power. Any questions on that particular situation before we go on? All right. Next, we'll do the t squared. Minus 1/3 t squared minus 3/8 t squared. The common denominator of 3 and 8 is 24. So I need minus so many 24ths t squared minus so many 24ths t squared. And I'm getting those minuses from here and here. Okay. So minus 1/3 t squared, I need a 24 in the denominator. So I'm going to multiply the numerator and the denominator by 8, which gives me minus 8/24 t squared. Minus 3/8 t squared, I'm going to multiply by 3/3, which gives me minus 9/24 t squared. Okay. So now I've got minus 8/24 t squared minus 9/24 t squared, which would be minus 17/24 t squared. All right. Any questions there before we go on? Finally, the constant term. Let's see here. We'll do this in green. So we've got this one. Okay. Plus 1/2. Oops, I drew that to the wrong place. It goes all the way over here. Okay. Plus 1/2 plus 1/16 common denominator there is 16. So plus so many 16ths plus so many 16ths. And 1/2, we're going to multiply by 8/8 to get 8/16. And 1/16 is already just 1/16. 8/16 plus 1/16 is plus 9/16. So there's our final answer. Now, just a reminder, in WebAssign, don't use mixed numbers. So if you write 1 3/10 t to the fourth, it's not going to recognize that as 1 3/10. Also, don't punch it into your calculator and get some decimal big long thing and then round it off. For instance, 2/3 is not equal to 0.6. It's 0.6 repeating. So if you've got 2/3, just leave it as 2/3 kinds of things. Okay. Again, any questions there? All right. Let's take a look at section, let's see, what are we on here? 5.6. Multiplying polynomials together. Okay, so first of all, let's multiply some monomials together. Let's say we've got 3y times 7y squared times negative y to the fourth. So we've got 3 times 7 is 21 times the negative 1 in front of the y to the fourth. So we get negative 21. And then y to the 1 power times y squared would be y cubed times y to the fourth power would be y to the 7th power. Okay. Any questions about that? All righty. Let's take a look at a monomial multiplied by a trinomial in this case. So we're going to distribute, and we'll get negative 8b to the fifth. Negative 4 times a minus 2 is plus 8b to the 1, 2, 3, fourth power. And finally, minus 4b cubed. Any questions about that situation? Then we looked at multiplying polynomials together, something like a plus 4 times a plus 5. And the authors call this FOIL, as in first, outer, inner, and last. So we've got the first, a times a is a squared. The outer, oops, went a little too far. A times 5 is 5a. The inner, 4 times a is 4a. And the last, 4 times 5 is plus 20. Then, combining like terms, a squared plus 9a plus 20. And notice I'm writing my answer in standard form, descending powers of the variable. A squared, a to the first degree, a to the 0 degree if you put it there, but anyway, or no a at all if you want to think of it that way. Let's take a look at multiplying two binomials with fractions. 8t minus 1/2 times 4t minus 5/2. 8t times 4t is 32t squared. 8t times minus 5/2 is minus 8t times 5/2. We'll come back and we'll simplify that in the next step. Minus 1/2 times 4t and minus 1/2 times minus 5/2. Any questions so far on that? All right, so I've got 32t squared. The 8 and the 2 reduce down to 4/1. So minus 4t times 5 minus 20t. Then minus 1/2 times 4t, the 4/2 reduces to t/1. So minus 1 times 2 times t is minus 2t. and then minus a half times minus 5 halves. Recall that when you're multiplying fractions, you multiply straight across. Negative times negative is positive, 5/4. Again, any questions there? All right, combining like terms, we get 32t squared minus 22t plus 5/4. All right. Let's say we're multiplying a binomial times a trinomial. So 3x plus 1 times 2x squared minus 3x plus 1. So we're going to take each term in the binomial and multiply it by each term in the trinomial. So 3x times 2x squared is 6x cubed. 3x times minus 3x is minus 9x squared. 3x times 1 is plus 3x. Then a plus 1 times 2x squared is plus 2x squared. Plus 1 times a minus 3x is minus 3x. And plus 1 times plus 1 is plus 1. Combining like terms, those are like terms, and those are like terms. So we get 6x cubed minus 7x squared. Those cancel, and then plus 1. Okay, let's see here. All right, let's go on to section 5.7, which was special products. So if we have something like this, that says we have two factors of the base being y plus 7. So this is y plus 7 times y plus 7. It's not y squared plus 7 squared. That is the common mistake that people make. All right, so then after we expand it, we FOIL it together. Y squared plus 7y plus 7y plus 49, y squared plus 14y plus 49. And then let's say we've got something like this. X plus 4 the quantity cubed. Again, that is not that. It is x plus 4 times x plus 4 times x plus 4. We have three factors of the base being x plus 4. So we're going to multiply two of them together to get the result, and then take that times the third. So we get x squared plus 4x plus 4x plus 16. Combining like terms, x squared plus 8x plus 16, and then we're going to take that times that last factor of x plus 4. So now we've got x cubed plus 4x squared plus 8x squared plus 32x plus 16x plus 64. Combining like terms, those go together, those go together. X cubed plus 12x squared plus 48x plus 64. All right.
How did you get the x squared? Wasn't it supposed to be 8? Oh, well, never mind.
You see it?
Yeah.
Okay, all righty. Be careful, because let's say you've got this versus this. Here, you're adding. So you'd add like terms and you'd get 12x squared. Here, you're multiplying, so you get 32x to the fourth. So you've got different rules for different operations, so be really careful with that. Okay. Let's see here. Let's take a look at section 5.8, which was dividing polynomials. We started out with dividing monomials by monomials, okay? And so let's say we've got something like this, 22b to the 9th power divided by 6b to the 6th power. I can reduce the 22 over 6 to 11 over 3 by dividing the top and the bottom both by 2. Then dividing two powers with the same base, b to the 9th over b to the 6th is b to the 9 minus 6, or b to the 3rd power. So this becomes b to the 3rd power, okay? So I end up with 11b cubed over 3. And you could write it that way, or you could write it 11/3 b cubed. Be careful, though, that you don't put the b cubed in the denominator. So it either goes in the numerator or straight out from the coefficient that's the fraction, okay? Again, don't take 11/3 and write it as 3 2/3. WebAssign will not accept it. And typically, it's not just WebAssign. You just don't typically use mixed numbers as coefficients, okay? All right. So whenever I say that, then somebody comes up with one, but most often you don't use that. Then we have a polynomial divided by a monomial. So we've got -25 x squared y cubed plus 30 xy squared minus 5xy all over -5x squared y squared. So if we have a polynomial divided by a monomial, we rewrite each term in the numerator divided by the monomial term in the denominator. Watch your signs carefully. Okay, so we get that. Now we're going to go back and reduce term by term. -25 over -5 is 5 over 1. X squared over x squared would be x to the 0 power, or just 1. Y cubed over y squared would be y to the 1 power. So I've got 5 times 1 times y to the 1 power all over 1. So basically I've got positive 5y. Any questions there? Okay. Next term, 30 over -5, -6 over 1. X over x squared, x to the 1 minus 2 power is x to the -1 power. Y squared over y squared, y to the 0 power, or just 1. Okay. So I've got what, a -6, so -6. But then I could take this and move it downstairs and make it x to the 1 power. So I get that. Okay with that? And then finally, 5 over -5 is -1. X over x squared is x to the -1. Y over y squared is y to the -1. But I'm subtracting a negative, so that's going to be like adding a positive. That's going to go downstairs and become x to the positive 1 power. That's going to go downstairs and become y to the positive 1 power. Okay. So there's our final answer. Any questions there? All righty. Now, let's say we have a polynomial divided by a polynomial. Divide, let's see what it says here, x squared minus 5x plus 6 by x minus 3. So you'd have x minus 3 as the divisor outside, x squared minus 5x plus 6 as the dividend inside. Note that the dividend and the divisor should both be in descending powers of the variable. In this case, they are. So then I take the leading term inside divided by the leading term outside. X squared divided by x, which is x, goes there. Then we take that x times the divisor, x minus 3. Distributing, we get x squared minus 3x, which goes there. Then we draw a line and subtract that entire quantity from what's up above. We change subtraction to addition of the opposite, as if though we were distributing the minus sign. So we get plus, minus, plus. X squared plus negative x squared is 0. Negative 5x plus 3x is negative 2x. Bring down the next term and continue the same process again. Take the leading term inside divided by the leading term outside. Negative 2x divided by x is negative 2. So we put minus 2 up there in the next column over. Negative 2 times x minus 3, negative 2x plus 6, which we write up here. We draw a line and subtract it from what's up above. Change subtraction to addition of the opposite. Negative 2x plus 2x is 0. 6 plus negative 6 is 0. No remainder. So our answer is x minus 2. Any questions on that example? Okay. Let's say we've got the following: 4x squared plus 6x minus 1 all over 2x plus 1. So now the divisor, 2x plus 1, the dividend, 4x squared plus 6x minus 1. Inside and outside, they're both in descending powers of the variable. So we take the leading term inside divided by the leading term outside. 4x squared divided by 2x is 2x. We take the 2x times the divisor. We get 4x squared plus 2x. We're going to subtract that quantity from what's up above. We'll change it to addition of the opposite. 4x squared plus negative 4x squared is 0. 6x plus negative 2x is 4x. Bring down the next term, minus 1. Start the process all over. The leading term inside divided by the leading term outside. 4x divided by 2x is 2, so plus 2. 2 times the divisor, 4x plus 2, which goes there. Subtract it from what's up above, change it to addition of the opposite. 4x plus negative 4x is 0. Negative 1 plus negative 2 is negative 3. So we have 2x plus 2 plus negative 3 over 2x plus 1. And there's that answer. Any questions there? All right, let's see here. Let's take a look at this one. X plus 3 divided into negative x plus 2x squared minus 21. Well, the inside, the dividend is not in descending powers. So I'm going to rewrite this. X plus 3 outside and inside 2x squared minus x minus 21. And now we're good to go. So we're not going to use that because it wasn't in standard form. All right, our descending powers. We're going to take the inside leading term divided by the outside leading term. 2x squared divided by x is 2x. 2x times x plus 3 is 2x squared plus 6x. We're going to subtract that quantity from what's up above, change it to addition of the opposite. 2x squared plus negative 2x squared is 0. Negative x plus negative 6x is negative 7x minus 21. So we'll start all over. Leading term inside divided by leading term outside. Negative 7x divided by x is negative 7. So we put minus 7 up there. Minus 7 times x plus 3, negative 7x minus 21. Write it over here. Subtract it from what's up above. Change it to addition of the opposite. Negative 7x plus 7x is 0. Negative 21 plus 21 is 0. So we have that answer. Okay. And then finally, let's say we've got this. Okay. So outside, we're going to have a minus 1. Inside, we need to fill in the missing powers of the variable in this polynomial. So we've got a cubed plus 0a squared plus 0a minus 1. Okay. Leading term inside divided by leading term outside. A cubed divided by a is a squared. A squared times a minus 1. A cubed minus a squared. Subtract this quantity from what's up above. Change it to addition of the opposite. And add up the columns. A cubed plus negative a cubed is 0. 0a squared plus a squared is a squared. Bring down the next term, the 0a. Start the process over. Leading term inside divided by leading term outside. A squared divided by a is a. A times a minus 1. A squared minus a. A squared minus a. Subtract that quantity from what's up above. Change it to addition of the opposite. Add up the columns. A squared plus negative a squared is 0. 0a plus a is a. Bring down the next term. Start the process over. Leading term inside divided by leading term outside. A divided by a is 1. So plus 1. 1 times a minus 1 is a minus 1. Subtract that quantity from what's up above. Change it to addition of the opposite. A plus negative a is 0. Negative 1 plus 1 is 0. So this problem has no remainder either. Okay, well, do you have anything that I didn't cover that you'd like to talk about? All righty. So I'll be back this afternoon at 1:15 with an office hour. Tomorrow morning, there will be no Zoom meeting, okay? So basically you have from now until tomorrow night at 11:59 to complete your test online. Once you start it, the clock is ticking. Again, if there's problems that when you're all done, you don't need to show your work in WebAssign, but when you're all done, if you missed problems and you want me to look at it to see about partial credit, send in the work, email it to me. That led to the wrong answers. Don't correct it. Send in what you actually used to get the wrong answers. All righty, I'm going to stop the recording and I will, if not before, I'll see you on Monday. Don't forget your test is tomorrow.